The universe is vast and full of wonders, from the twinkling stars that light up our night sky to the mysterious galaxies scattered far beyond what our eyes can see. For millennia, space has fascinated humanity. We gaze upward and wonder about the unknown, trying to imagine what lies beyond our world. Now, with the advent of new technology, we have a powerful tool that brings these mysteries closer than ever before: the James Webb Space Telescope. Acting as a giant eye in the sky, Webb lets us see things in space that were once completely hidden. It can peer deeper and farther than any telescope before it, unlocking secrets that help us write a new chapter in our understanding of the cosmos. Unlike ground-based telescopes that struggle with Earth's hazy atmosphere, the James Webb Space Telescope floats far from our planet, positioned in space where nothing obstructs its view. This vantage point lets it capture breathtaking images and critical scientific data from distant galaxies, stars, and even planets. Every day, it sends back fresh information that forces us to rethink our ideas about the universe. It's not just a telescope, it's a cosmic time machine, offering us glimpses of an ancient universe, showing us what it looked like billions of years ago. Webb is a technological marvel, the result of decades of scientific ambition, engineering expertise, and international collaboration. Launched in December 2021, it is the most advanced space observatory humanity has ever built, designed to tackle some of the biggest questions we can ask. How did the first galaxies form? What are other worlds like? Could life exist elsewhere? The telescope is named after James E. Webb, a former NASA administrator who played a crucial role during the Apollo program, guiding the agency through one of its most ambitious eras and laying the groundwork for landing humans on the moon. Yet Webb's mission is even more audacious, not to extend our reach within the solar system, but to carry us back in time to the edge of the observable universe itself. Webb achieves this feat by capturing the faintest light from the farthest corners of space. Because of the finite speed of light, looking far away is the same as looking back in time. By detecting light emitted billions of years ago, Webb shows us what the universe looked like not long after the Big Bang. One of its most important capabilities is its ability to see infrared light, which sets it apart from predecessors like the Hubble Space Telescope. Infrared light can penetrate cosmic dust clouds that block visible light, revealing stars, planets, and galaxies that would otherwise remain hidden. Many of the universe's oldest galaxies emit most of their light in the infrared, making Webb the ideal tool to study them. As the universe expands, the light from these distant galaxies stretches into longer wavelengths, a phenomenon known as redshift. This redshift means that the oldest, farthest galaxies now appear in the infrared spectrum, invisible to human eyes but perfectly suited to Webb's instruments. By seeing this stretched light, Webb acts as a window to the universe's earliest moments, just a few 100 million years after the Big Bang, when the first stars and galaxies were born. One of the keys to Webb's power is its enormous mirror, over 6 meters wide, far larger than any previous space telescope. Made up of 18 hexagonal, gold-coated segments, the mirror works as a single unit to collect as much light as possible, capturing extremely faint signals from the universe's most remote corners. This massive collecting area allows Webb to see fainter objects than we ever could before. Its instruments are exquisitely sensitive, designed to detect even the tiniest glimmers of ancient light. Webb can study the atmospheres of exoplanets, search for signs of life, and reveal secrets that were hidden in the darkness of space. But Webb is not only about cutting-edge technology, it's about what that technology reveals. Recently, Webb made an astonishing discovery that has excited astronomers and space enthusiasts worldwide. It detected a new type of star cluster in a distant galaxy, something never before seen. This cluster is a true cosmic nursery, filled with hundreds of young stars just beginning to ignite. Imagine a vast region where countless suns are being born, surrounded by swirling clouds of gas and dust glowing with their first light. These regions are critical to understanding how stars form and evolve, providing clues about the conditions necessary for star birth and how these young stars help shape the galaxies they inhabit. The cluster was found in the galaxy NGC 2673, a distant spiral galaxy that has long fascinated astronomers. Located millions of light-years from Earth, its light has traveled across the universe for unimaginable spans of time, beginning its journey long before humanity existed. Within this galaxy, Webb's instruments revealed not only the dense cluster of young stars but also details that had previously been impossible to study. Among the surprises was the presence of several massive stars, giants much larger and brighter than our own Sun. These massive stars burn through their fuel quickly and die in spectacular explosions called supernovae, releasing enormous energy that can shape the surrounding environment. These supernovae don't just end a star's life, they help create the elements necessary for new generations of stars and even for life itself. The intense energy from these explosions and the radiation from massive stars can trigger the birth of new stars nearby, acting like cosmic engines that drive the evolution of entire galaxies. By studying these massive stars and their clusters, scientists are piecing together the grand story of how galaxies like our Milky Way formed and evolved. Yet this remarkable discovery is only the beginning. Each new finding with Webb raises fresh questions. Why do some star clusters contain so many massive stars while others do not? How exactly do these giants influence the development of their galactic neighborhoods? Scientists are eager to use Webb to study these puzzles, deepening our understanding of the universe's history. By examining these distant clusters, we aren't just learning about faraway galaxies. We're building a timeline of cosmic events that helps explain where we came from. Every photon of light captured by Webb represents a journey millions or even billions of years in the making. Seeing these ancient structures is like reading a cosmic history book, with each observation adding new pages. This doesn't just satisfy curiosity, it connects us to the universe, giving us a sense of belonging in the vastness of space. As we learn more, we realize how much more there is to explore, each discovery sparking the next. And Webb itself is an incredible feat of engineering. Did you know it's as big as a tennis court? Imagine a golden-eyed observatory the size of your local sports field floating far above Earth. Its sunshield alone is roughly the size of a tennis court, carefully designed to protect the telescope from the sun's heat while keeping its instruments icy cold. Getting something that massive into space wasn't simple. Engineers had to fold it up like an origami masterpiece so it could fit inside the rocket's nose cone. Launching it was only the beginning. Once in space, Webb had to perform a complex, delicate unfolding process, extending its mirrors and sunshield like a giant flower blooming in zero gravity. This slow, cautious deployment was a breathtaking ballet of precision. There was no way to send astronauts to fix it if something went wrong. Every move had to be perfect. And it was. Webb's mirrors are coated in a thin layer of gold to help them reflect infrared light with maximum efficiency, giving it the power to see the faintest, oldest objects in the universe. But Webb isn't just a telescope, it's truly a time machine. By capturing light that began its journey billions of years ago, it lets us see galaxies and stars as they were before our solar system even existed. Each observation is like receiving a postcard from the dawn of time, filled with secrets about how the first stars and galaxies formed and how the universe itself has changed over time. Behind every breathtaking image Webb sends back is the story of the people who made it possible. Scientists and engineers from around the world, men and women of many backgrounds, worked together for over 2 decades to bring this ambitious project to life. They overcame countless challenges, sharing ideas and innovations to build a telescope that pushes the limits of what is possible. Their dedication is a shining example of what humanity can achieve when we work together toward a common goal. Ultimately, space exploration isn't just about technology or science. It's about curiosity, teamwork, and the human spirit. It's about our shared desire to understand where we come from and to discover the wonders that await us among the stars. Every new discovery Webb makes isn't just for scientists, it's for everyone. It's a reminder that the universe is full of stories waiting to be told. Exploring space also delivers benefits that reach back to Earth. It inspires us to develop new technologies and solve challenging problems. Many everyday items, from GPS navigation to weather forecasting, have roots in space science. Space exploration also unites people. It brings countries and cultures together in a shared quest for knowledge, reminding us that the challenges we face in space are not so different from those we face on Earth, like climate change or managing our resources wisely. In the end, as we peer into the depths of space with the James Webb Space Telescope, we're reminded of the infinite possibilities that await. Each discovery not only expands our understanding of the cosmos but also enriches our lives here on Earth,